Hello students, welcome to this particular session. In this session, in the next 20-25 minutes, we will be discussing about a physical quantity and the classification of physical quantity, basically scalars, vectors, and then we will try to find out the difference between scalar quantities and vector quantities, and then examples on scalars and vectors. Right? Before we start, we need to understand physical quantity. As I've told you, physics, it's basically a science which deals with the study of laws of nature and the natural phenomena. Whatever is happening around our surroundings or vicinity, some phenomena is definitely involved. And the study of those natural phenomena comes under the category of physics. Right? And in order to understand those phenomena, we need some physical quantity. So as to have a quantitative approach, mathematical approach. So here comes the definition of a physical quantity. A physical quantity is a quantity in terms of which the laws of physics can be expressed. So these are the quantities in terms of which the laws of physics can be expressed. That's physical quantity. Now, physical quantities can be divided into various categories. There are scalars, there are vectors, there are phasors, there are tensors. So scalars, vectors, tensors, phasors. But in this session, I will restrict myself to only scalars and vectors. So we will discuss scalar physical quantities and vector physical quantities, right? So, first you need to understand the basic difference. Scalars are those physical quantities having only magnitude but no direction. They possess only magnitude. I'll give you an example. Let me ask you a question. How much is the distance traversed by you in going from your home to school? If you say 5 kilometer, 5.2 kilometer, that is, you are indicating the magnitude. You are not indicating anything about the direction or the location of your destination. So that will be scalar quantity. So only if you are mentioning 5 kilometer, it will be a scalar quantity. If you mention 5 kilometer and along with that you mention the latitude, longitude, so it means that not only you are giving the magnitude of the distance, but also you are indicating the direction, in which direction to move so as to reach that destination. That will be a vector quantity, which will have two parts. One, the magnitude, the other, the direction. So this is the basic difference. So scalar quantities are those physical quantities having only magnitude, but no direction. While on the other hand, vectors, these are those physical quantities which are having both magnitude as well as direction. So let's discuss some other examples as well. Like mass and weight. Mass is the amount of matter contained in the body. Suppose the mass of a body is given to be 3 kg. So that's the amount of substance contained. Amount, it's a numerical value. It's basically the magnitude. So mass represents only the magnitude or the quantity or the numerical value of the matter contained in the body. It is scalar quantity. While on the other hand, weight is the force exerted by the earth on that body. Right? It is actually the gravitational force. So that is weight. So it gets attracted towards the center of the earth, that is, it gets attracted in a particular direction. So there not only the magnitude but also it possesses direction as well. So weight must be a vector quantity. So there are various other examples. So examples are, one is just now we have discussed distance. Here it will be displacement. Distance is a scalar quantity, while displacement, having both magnitude and direction, will be a vector quantity. Then another example, speed. Over here, velocity. Then mass. It's a scalar quantity, while weight, it's a vector quantity. Work, energy, these all are the physical quantities which possess only magnitude but no direction. So they comes under this category, scalars. While here, force, acceleration, force, momentum, these are the terms which we will be discussing in the later section. Impulse, we'll discuss about these terms in detail. So these are few examples of physical quantities which are scalars and vectors, right? So scalars are those quantities which possess only magnitude but no direction, while vectors are those physical quantities which possess both magnitude as well as direction, right? And these are examples of scalar quantities and vector quantities. Now what we'll do is, we'll try to bring out the difference between distance and displacement. Then in the next section we'll discuss speed and velocity. So let's start with distance and displacement. Distance, you're aware of it, isn't it? Suppose a body travels from point A to point B, following any arbitrary path. The body may follow any path, right? Suppose this is A and this is B. A body moves from A to B following any path. It can be any path. It can be curved, it can be straight, or any path. This is the path followed by the body in reaching from point A to its destination, point B, right? The length of the actual path covered by the body, that is known as distance. Length of the actual path which the body follows. So I'm talking about the magnitude. So it actually tells the body how far it has moved, right? The actual path, the length of the actual path covered by the body between the two given points, that is distance. While on the other hand, displacement. Displacement is the shortest distance and it should be always in a unique direction. Shortest means it should have a unique direction. So the shortest distance between the 2 points between which the body moves is known as displacement. So what will be the shortest distance between A and B? It should be given by a straight line, right? So if I draw a straight line from point A to point B, then this will be displacement. And it is represented by an arrow like this. It is represented by an arrow. The tail of the arrow should coincide with the initial position of the body. The body starts its journey from point A. So point A is the initial point. So there are two parts of the arrow. This is the tail and this is the arrowhead. So the tail of the arrow indicates the initial position of the body, while the arrowhead should coincide with the final position or the destination of the body, right? So displacement is the shortest distance between the 2 points and it must be in a unique direction. That's displacement. So let's check out another difference. So this is distance and displacement. So as I've told you, distance is the actual path. Distance covered by a body may be defined as the length of the actual path covered by the body between the two given points. So it is the length of the actual path. While displacement, it is the shortest path. It is the shortest path between the 2 points in a unique direction. And as I told you, displacement, it has to be represented by an arrow. The tail of the arrow should coincide with the initial position, while the arrowhead represents the final position of the body. So that's the actual definition. Now look, it indicates the length of the actual path covered by the body. Nothing regarding the direction. So it must be a scalar quantity. So it possesses only magnitude but no direction. So therefore distance is a scalar quantity. While on the other hand, displacement is the shortest distance between any two given points in a unique direction. So direction term gets involved over here. So displacement is a physical quantity possessing both magnitude as well as direction. So it must be a vector quantity. Third, distance covered by a body between any 2 points, it is always having some finite value, finite positive value. It can't be 0, it can't be negative. Why it can't be 0? Because it is in motion, so it must have covered some path. So the length of that path is distance. So if the body is in motion, the distance covered by the body can never be 0. It needs to be a positive finite quantity. So distance covered by a body is always positive. It can't be negative, obviously. So distance is a positive quantity. Distance is always greater than 0. When I write greater than 0, means it is positive. While on the other hand, displacement, it can be 0. It can be positive or it can be even negative. We'll discuss it. We'll discuss various examples concerning this particular concept. So, displacement, it can be 0, it can be positive, it can be negative. When the displacement of a body will become 0? Only when the initial position of the body coincides with the final position of the body. Now look, suppose a person moves from A to B following any path and then again he comes back from B to A. So his initial position was A and after completing the entire round trip he again comes back to point A only. So initial and final position coincides. So whenever such a scenario happens, such a scenario arises where initial point coincides with the final point or initial position of the body coincides with its final position. In such a case, displacement of the body would be 0. Right? I'll give you an example where the displacement can be negative as well. Let's take this example. This is positive x-axis, this is the origin. Suppose this is 5, this is 10, this is 15, 20, 25, 30, 35. It is distance, suppose, in meters. Right? It is in meters. Let us consider this to be point A, this to be point B, and let us consider this to be point C. And this is the negative x-axis. This is the negative axis. Suppose this is minus 5. Right? A body, suppose it starts from the origin. The initial position of the body is at point O. A body starts from the origin and it reaches point C, passing through point A and B. It reaches point C like this. Moving along a straight path, it reaches point C. On reaching point C, what will be the distance and displacement of the body? Since it is moving along a straight path, so distance would be naturally equal to the displacement. When the body moves along a straight path, that will be its shortest distance between the two given points, isn't it? So that is the case when the displacement of the body becomes equal to its distance. So in case the body moves along the straight path OC, then the total distance as well as displacement would be 30 meters. Now suppose the body reaches point C and it comes back to point B. Suppose the body goes to point C, and then again it comes back to point B. So initial position was point O and final position was point B. So what is the displacement? This is the initial position, this is the final position. So displacement will be 25 meters. While what will be the distance in this case? The body is going from O to C, 30 plus is coming from C to B, that is 35 meters. So if the body moves from O to C and then again comes back to point B, then the distance would be 35 meters while the displacement would be only 25 meters. Understood now? Again, if the body moves from point O, reaches point C, and again it comes back to point O. So it follows a round trip. O to C and then C to O, back. So what will be the distance covered? What is the length of the actual path covered? It will be 30 meter plus 30 meter, that is 60 meter. That will be the distance, length of the actual path covered. While what will be the displacement? The body has started from this position and eventually he reaches this position. His final position coincides with its initial position. So displacement would be 0. Now imagine a situation when the body moves from point O, reaches point C, and he again comes back at point O and then exceeds this point and reaches this point D. Suppose the body moves from point O, reaches point C, and then again turns back and eventually crossing point O, it reaches eventually final point D. So this is the initial position and this is the final position. This is the initial position and this is the final position. So in this case, what will be the total distance covered during the entire journey? It will be 30, then again 30, 60, and this one is 5. So 65 meters will be the total distance covered. Look, the body starts from here. It goes to point C, so it is covering a distance of 30 meters. It again comes back to point O, so again 30 meters is covered, and then he goes to point B. This is the final position. So again plus 5 meters. So 30 plus 30 plus 5. So it will be 65 meters. That will be the total distance covered by the body. While what about displacement? This is the initial position, this is the final position. So I've told you, displacement is to be represented by an arrow whose tail must coincide with the initial position and arrowhead must coincide with the final position. So this is the displacement. So displacement is 5 units or rather 5 meters towards the negative x-axis. So here you can write displacement as minus 5 meter. Have I made myself clear? So what I meant to say is that in this example we have considered, or rather we have taken such situation where the displacement can have positive value, the displacement can have 0 value, as well as the displacement can attain negative value. So here distance can have only positive value, here the displacement can have positive value, it can have negative value, it can also have 0 value. I'll illustrate with some other examples as well. First, let's try to complete this topic, right? Let's try to bring out some other points of difference or some important points relating to distance and displacement. Okay. Distance is always greater than displacement. Whether the body moves along a straight path, whether it is moving along a plane following zigzag path, it doesn't matter. Distance or the length of the actual path covered would be always greater than displacement. Distance can be equal to displacement provided the body is moving along a straight path. That is, suppose this is point A, let us consider this to be point B. A body moves from A to B following this straight path. So suppose the distance is 30 km. So what about the distance in this case? Length of the actual path covered, that is 30 km. What about the displacement? Again, the straight path, it is the shortest distance between the points A and B. It is eventually the displacement as well. So which is also equal to 30 km. So remember, whenever, this is a very, very important point. Please mark my words. Whenever a body moves along a straight path, that is, I am talking about one-dimensional motion. So whenever a body moves along a straight path, the distance covered by the body is equal to its displacement. Now, in the same case, if the body moves from A to B following this path, okay, following this path. So naturally, this straight line would be the shortest distance, and this length of the actual path followed would be greater than this shortest path, isn't it? So in this case, distance would be naturally greater than displacement. Displacement can't be greater than distance. It is always distance which is greater than displacement. So this is a very, very important conclusion. So what you conclude is, distance is always greater than displacement. And in one-dimensional motion, it can be also equal to displacement. So distance is greater than or equal to displacement. So you are supposed to make use of this inequality. So always remember, distance in one dimension is equal to displacement, but otherwise it is always greater than displacement. So combining both, we can safely conclude that distance is greater than or equal to displacement, right? So it can be further stated in this particular manner as well. The ratio of distance to the displacement covered by a body is always greater than or equal to 1. So this is a very, very important conclusion, right? Do remember this particular statement. There is some other difference as well. Displacement, it doesn't tell us about the actual path followed by the body, isn't it? It is simply the shortest distance between the two given points. So displacement do not indicate or do not tell us regarding the actual path covered by the body. The actual path covered by the body is given by the distance in numeral form, in magnitude only. So this is essentially the basic difference between distance and displacement. In the next lecture, we will discuss some very, very interesting numericals based on distance and displacement.